Howdy, howdy, this is Mr. Potter. In this lesson, we're going to talk some more about methods that give us string. Something that's important to remember is that these methods that we're talking about, they actually return a string. They don't actually change a string. Remember, strings are immutable. We cannot change strings. So what I'm going to do is I'm going to start with some strings. So I'm going to call this string S1, and I'm going to say it contains a man, a plan, a canal, Panama. So just to have some string that we're going to work with. And the first thing I want to talk about is the replace method. And what the replace method does is it replaces a char with another char, or a string with another string. So if I do s1.replace and I tell it to replace all of the A's with O's, and then I system.out.println S1, I get the usual expected outcome. Namely, because strings are immutable, I should get back my original string. A man, a plan, a canal, Panama. I actually have to do an assignment, so I'll do something like string S2 gets this S1.replace, and if I print S2 out, then I'm going to see amon, oplan, okanal, ponemo. So the idea here is that I've replaced all of the A's with O's in here. If I want to replace more than just one char, I can do that with the replaces as well. I can say string S3 gets S1.replace, and I can replace all of the ANs with OOSH. And so if I system.out.println S3 out of this, then what I'm going to see is, after a few minutes of thinking, a moosh, a plush, a kushal, pushamal. So I can actually replace both one char with another char, or I can replace a string with a string. What I do not have the luxury of is replacing just a char with a string. if I try and do this, system.out.println S4, I'm actually going to get an error. I can't mix and match, and that's really the point here, is that I can't take so the error I end up getting here is it says that replace char is not applicable, and char sequence is not applicable. There's only two different things that I can do, and I can kind of get around this by not dealing with the char a, but with the string containing one character in length a. And of course, this will do what I'm expecting it to do. And so what I end up getting is a mean clean me. So I can do this replacement idea, the idea that I can replace some part of my string with some other part. But I have to remember that strings are immutable. I can't just do s1.replace. I have to physically assign it to a new string. So that's one thing I need to be aware of. Another thing that I need to be aware of is that sometimes string S5 gets, let's go ahead and create a in.next. So I'm going to need to create a scanner. So scanner in gets new scanner system.in, and I'm going to need to go up to the top and import java.util.scanner. And what I want to do is, if I print S5 out, after I do this, it's going to print the things that I'm expecting. I'm going to see a mana, plana, canal, Panama. I'm going to see omona, plana, canal. I'm going to see all the different ones that we've created. But now it's waiting for me to type something. So if I say something like space, hi, space, and hit enter, notice that what I get is I get a whole bunch of leading spaces, and you can't see them, but I also have trailing spaces here. And that can actually cause some issues. For example, if I was to do integer.parseInt or double.parseDouble, those spaces would actually cause an error. And so what I can do is I can create a new string, let's call it S6, and I want to get S5 dot trim. And what trim does is it takes the white space off the very beginning and the very end of a string, so that all I have is just the essence of a string. In other words, the non-white space characters. And I'll show you what I mean that in a little bit more detail in just a moment. So if I change this to print out S5 plus an exclamation point, and then I print out S6 plus an exclamation point, you can see where the white space actually ends. Both for S5, which is my first string, which I'm going to load up on some white space at the front and at the back. So I'm going to put some spaces here. Hello there. Now, as soon as I hit enter, S5 has the hello with the exclamation point, and then I see this hello here. So the fact that I've got all the white space in the front basically gets taken care of. What I could actually do is I could actually, instead of saying S5 gets in.next, I could actually change this to S5 gets, let's do tab, space, hello, space, slash n. And so what's going to happen is I'm going to see all of these tabs, this blank spaces, and these new lines for my string S5. Let me scroll this up a little bit so you can see this. So here is S5. It's all of these tabs plus the spaces plus hello plus more spaces plus new lines, and the exclamation point gets printed afterwards. But when I run trim on it, it gets rid of all the leading white space, including the tabs. It gets rid of all the trailing white spaces, including the new lines. And I get something that's very nice, this hello, with no space in front and no space in back. So the trim is going to actually help me to kind of standardize my input so that if the user puts too many spaces in front of or too many spaces afterwards, it's not going to mess me up. So that's the second thing I want to talk about, is this trim method. Again, remember that if I just put s5.trim and then system.out.println, S5 plus, because strings are immutable, it's not going to change S5. So here's the first time I printed S5 with all the spaces. Here's the second time I printed S5. S5 doesn't actually trim. It doesn't change itself. It's immutable. What's actually happening is I'm creating a string at this level, and then it's just kind of being tossed into ether. There's no storage for it, and there's no doing anything with it in a method like printing it to the screen. So the final thing I want to talk about is I want to talk about a static method called valueOf. And what valueOf does is it takes the primitives that we're used to and actually kind of upscales them to a string. So I can say string S7 gets string.value of 3. Notice this 3 here is not in quotes, but what's happening here is this actually creates a string whose contents include the string version of 3. So I can system.out.println S7, and it'll print out a string that contains a 3. So I can see that right there. I can do this for an int. I can do this for a double. I can do this for a boolean. I can do this for a char. Any of the primitives that we've talked about, I can stick in here. So I can do this to the lowercase letter u if I wanted to. And it basically promotes everything to a string. This is just one way to do it. We've already talked about how we can do this using concatenation. I mean, I've talked about how I can do something like string S8 gets quote plus 3 plus 4 plus 5. And what happens is going to take the string plus the first int, which makes it a string, then takes the string plus the second int and makes it a string, and then takes the string plus the third int, makes that an even longer string. So I can system.out.println S8, and what I'll see is a concatenated string that contains the ints 3, 4, and 5 all pressed together. This allows me to, this is just basically another way of promoting these ints or doubles or chars or booleans to a string, not using concatenation, but just taking the value in and of itself. So it's an interesting tool to have. It's not necessarily the most efficient way, just like constructing a string with the new constructor is not necessarily the best way to create a string, but there are certain situations where this is preferable, and we'll talk about those situations later in the course. Key thing to remember about strings is that they're immutable. You cannot actually change the contents of a string. You have to do it through reassignment, through some of the methods that we've talked about. Concatenation discards the old string and builds a new string. This replace discards the old string. Well, it's still stored in S1, but it creates a new string, which we had to store. If we didn't store it, we would lose it. Kind of like what we did down here with this S5.trim. Trim gets rid of the white space before and the white space afterwards. But again, it returns a string, so I have to store that string somewhere. Replaces all occurrences of one character with another character, or one string with another string. But again, it creates a new string, and I have to do something with it. And that's really probably the most important thing to remember about this series of lessons, is that we have accessors, and we can access the data inside of a string, but we can't change what's in a string. All we can do is create new strings. So once again, this is Mr. Potter. Thank you for watching. Have a great day.